That's a large portion of our lesson today. That triangles, every triangle adds to 180 degrees. I'm actually going to give you that in theorem form in a second, which you don't have to report if you don't want to. You won't need that theorem for your proof. But all angles add to 180. All angles add to 180. And one more time. All angles add to 180. Only in a triangle. Only in a triangle. In a triangle. In a triangle, the angles add to 180. Okay. Now, I'm actually going to skip a slide and jump straight into something. Man, I'd never dreamed in a million years you guys would finish my sentence like that. That was super. Okay. We are going to be section 4.1. Apply triangle sum properties. 4.1. Man, you see that kind of stuff happen on movies where all the kids break out in unison. And you think that's staged. That's what would happen. No, I didn't. I said I was going to say I wouldn't say that. Oh, come on. 40% of your week next week will be less than 3. 40%. What about what? No. Okay. Apply triangle sum properties. But luckily, hey, what do you think this says? Triangle sum to 180. That's like half the lesson. That's right. So, first thing, there are interior angles of a triangle and there are exterior angles of a triangle. No, that's not going to happen again. I don't know who threw that. That better not happen again. What? I don't even know. Something hit me in the head. I know somebody threw it. It's all fun and games. The stuff our kids are from. Okay. You don't have to write any of this. The only thing you need to know is that interior angles of a triangle are the ones on the inside of the formed triangle. The exterior angles are angles formed, like if you were to keep drawing the sides of the triangle, they could be these kinds of angles. That's going to be fairly obvious to you most of the time, but I just wanted you to be familiar with interior, exterior. Any questions on that, interior, exterior? Okay. 3 types of triangles if you're going to call them by their sides. We're going to be classifying triangles by their sides today. And there's only 3 ways to do that. Scalene. Now, here's where vocab is going to come in to your next test. Scalene triangles means no sides are congruent. They're all different. Isosceles means that 2 of them are the same. Now, I always remember that because iso means like isolated, right? And there's like one side that's all by itself. It's not like the other. So, isosceles means one of them is isolated, the other 2 is the same. And equilateral, they're all the same. Now, how do you think this vocabulary is going to be used on the next test? There's going to be a triangle. It's not going to give you dashes, but it'll say, hey, one of those is isosceles. Find the sides. And you're going to need to know isosceles. That means 2 of them are equal, and you'll have to set them equal. Vocab, vocab, vocab. Isosceles. Questions about those 3 types of triangles? Scalene, none of the same. Isosceles, 2 are the same. Equilateral, they're all the same. Now, that's by their sides. We can also classify them by their angles, which is the next slide. I see some people writing, so I'll tell you what. On page, what page are you on? If you flip to page 217, we can go and start talking about the next slide. Page 217, the first 3 are what we just did. The next 4 are the angle ways to classify them. I'll flip the slide as everybody's got that in their notes who wants it. By angles. Now, it's the same exact names we've already talked about angles, because now it applies to triangles. Acute triangles means it has all acute angles, and we should all know what acute means by now. Less than 90. If it has all less than 90 angles, then it is an acute triangle. If it has a right angle, it'll be a right triangle. Now, outside the box question. Why can a triangle only have one right angle? Well, that's true. If it had more than one, it would be like, and you'd never be able to close it, right? And with just one more side. But, thinking in terms of numbers, why can a triangle only have one right angle? That's right. It equals to 180. If we had two right angles, 90, 90, that'd be 180 right there. We wouldn't have any degrees left for the third angle. So, you only ever have one right angle in a right triangle, and by that same exact logic, you'll only ever have one obtuse angle and an obtuse triangle. So why are you telling us this? Because every triangle has at least two acute angles. That doesn't mean they're all acute triangles. They all have to be acute to be an acute triangle. If they have a right angle or an obtuse angle, then that trumps the acute. Yes. So, right triangle, obtuse triangle. And then there's that last one we did. Equiangular. Every single equiangular triangle in the entire world is a 60, 60, 60. It has to be. Because if every triangle adds 180, then every equiangular triangle has to be 60, 60, 60. That's the only three angles that are the same that can add to 180. So if you want to write somewhere in your notes that every one of those will be a 60, 60, 60, that'll probably help you in the future. Yes, sir. Yes. Dude. Right? Excellent observation. Every equiangular triangle is also an acute triangle. However, when you're asked to classify them in your notes, you can just say equiangular. You won't have to say both. Good observation. Questions on that slide? Let's get to it. First one. Now, you don't have to write this. You do not have to write this. Just know it. All this says is that every triangle adds 180. That's all it says. Every one of them, ever, always, for your whole life, will add 180. Yes, that's true. Okay. Next theorem. Well, exterior angle theorem. Now, then we could, this would be a good proof question because it's actually not that hard to think about. The exterior angle theorem says anytime you have one exterior angle of a triangle, in this case it would be this one. If you have an exterior angle of a triangle, it's going to be the same thing as the sum of the other two interior angles. The logic behind that is very simple. Someone think about it for a moment and try to tell me, why do you think that has to be the same as the sum of the other two? Why does this have to be the same as the other two? Because these two form a linear pair. Let's look at this logically. Let's say this is 30. These are a linear pair. So what would angle 1 have to be? If this was 30, what would this have to be if they're a linear pair? 150. But what do all three angles of a triangle add up to? 180. So if they all add to 180 and this one is 30, how much is left for these two? 150. There's the logic behind it. Now, you probably want to write that down just because it's not as obvious. Although, you won't need it in a proof, I don't think. But you definitely are going to need to remember that. I think We may have one more thing of notes, and the rest of them is examples. Nope. We're getting straight into that's all the notes. Questions about any of the theorems we've done before we start looking at examples? Okay. A and B. Now, what do the directions tell us to do? All we have to do is classify the triangle by its sides and angles. We don't have to solve for anything. We just have to say what it is. So I'll do A, and I'll let you do B. A. Let's start with the sides. Are any of the sides equal? So it is a what kind of triangle? Scalene. It is a scalene, and what is it by its angles? Does it have a right angle? Does it have an obtuse angle? Yes. So this would be, and this is how you would answer it, this would be a scalene obtuse. And you could write triangle, but that's going to be the same on every question, so you don't have to. That is, and if you want to write it in the other order, that doesn't matter. Scalene and obtuse are the two words that give us the answer. Now, B. Who wants to take a stab at B? Rip? Is that a confident anyway? Go. Okay. All right. Half done. That's right. This is a right isosceles triangle, and that's all you have to do. Right isosceles. It does not. Isosceles is when two of the sides were equal. Scalenes were none of them equal. Isosceles are where both of them, or two of them equal. Let's look at some more. I'll call on random people to answer these. They're the exact same thing, but now we have three of them. Eeny, meeny, miny. Just. Number one. What kind of triangle is that? Are two of the sides equal? Scalene. Jensen, number 12. What is that? Number 2. Number 2. It's no. Cameron. Are you looking at number 3?
Oh, no.
Number 3, you're right. Number 3 is obtuse and isosceles. But that's not the one I asked about. Malik. Finish it up, Ariana. Actually, yes, but remember, when they're all the same, instead of saying acute, you're going to say equiangular. This is equiangular and equilateral. Now, I'll give you a quick way to do those. Here's a quick way to do that. Every triangle that is equiangular will also be equilateral. Does anybody remember, I'll be impressed if somebody knows this, does anybody remember what we said, if any polygon had all congruent sides and angles, what we called it? Back in chapter 1. It's an R word. Regular. If a polygon has all congruent sides and all congruent angles, it is called regular. So, equilateral, equiangular. That's a handful to say and to write. So if you just want to do it like this, if you see one of these triangles, if you just want to classify it as regular, I will consider that correct. So number 2 was regular, and Cameron did number 3. It was obtuse, isosceles. Remember, this is equilateral, equiangular, but we're just going to call it regular. All right, let's get down now. Now we have to use that vocab to solve these. Okay. What do you think we need to know to be able to solve this triangle? Does it use the sides at all? No. All we need to know is the angles. And what do I know about the angles? Yeah. They equal 180. So what are we going to do? That's right. If we know they add to 180, let's add the stinking things to 180. Just add them all up, set it equal to 180. All you got to do. So how many x's do I have total? 4 and 3, that's 7. 4x plus 3x gives us 7x. 90 minus 5 is 85, plus 11, 96. All that we did, all we did so far is like terms. 4x and 3x make 7x. 90 minus 5 plus 11 equals 96. How do I solve? Just subtract 96. The 84. Now what do I do? Divide by 7. And x equals 12. Working on it. Working on it. I don't know why I have so much energy today. I didn't even sleep well last night. Oh, not only did I not sleep well last night, my bed is like pushed against the wall. And this morning, my phone, see, I use my phone for my alarm clock. It fell behind like my bed, but like my bed was like boxing me out, so I couldn't like get to it. So like, I don't know about you guys, but the alarm that wakes you up is the worst noise in the world. Like, yeah, and I couldn't get to it, and my wife's getting ticked off. Like, it was awful. What? I find really annoying sounds, or it won't wake me up. Okay. Question. Oh wait. But wait a minute. Did I answer the question? No. What did it ask me for? The angles. So what do I do with that 12? Plug it in. That's right. Plug it in. 3 times 12 plus 11. 36 plus 11 makes that 47 degrees. Now, you could plug it into the other one. What's an easier way to find that last angle? Add 47, 90, subtract 180. Shabam. 43. And we're done. Well, they still add 180, just like they did earlier. So we know two of them. 47 plus 90, subtract 180, you get 43. Okay, let's look at some more. Almost. Okay, what did I give you today that looks anything like this? Did you just throw out a random vocabulary word? You said scalene? Well, that's actually true. It probably is scalene. But the exterior angle theorem said that this should equal what? If I had this one, it would add 180. It should equal the sum of the other two. Actually, that if I had been given this angle, then yes, these would equal 180. But when you're given these two, you just set them equal. 5x minus 2 equals the sum. That was theorem 4.2. 4.2 said exterior angle equals the sum of the other two. So solve. We're going to subtract the 2x from both sides. 5x minus 2x is 3x. Minus 2 equals 76. Add the 2. Divide by the 3. Wow. Very good. 26 divided by 3. Divided by 3. Am I done? No. Plug it in. Now, I assume you guys aren't going to want to write down or draw the picture today. So you actually need to label these angles. This is angle ABC. So angle ABC equals, what's 2 times 26? 52 degrees. And angle BCD is this one. Plug 26 into that. Oh, wait. Yes, that's right. What is it? 120. Is that right? That's not right, is it? Are you sure? That can't be wrong. Alright, it is. It's just gone crazy that they're perfectly supplementary. Which actually means this would have been an isosceles triangle. If I had asked you to find this angle, you now could, because these would add to 180 as would these three, and this would have ended up being 52 as well. Cool. Anyway, if you draw it out, you can just write it where it's supposed to go. Yes, if you think that's easier. Questions? I'll tell you what. Let's cut this lesson in half. Here's why. We're not doing anything new, but next thing we were going to do was we were going to look at some graph problems, and then we were going to look at some a little more complicated. So all we're going to do is kind of cut this lesson in half. And here's what we're going to do. All I want you to do for today, wait, I'm going to change this. Oh, hold on. Did I save this? Oh, no, I didn't. Hold on, let me save it first. Don't write that down. Not your assignment. Pre-cal. Oh, this isn't pre-cal. This is geometry. And this was 4.1. Okay, so this is 8 through 10, and I'm just going to make that all. Dadgummit. Alright, there's your assignment. That's it. Tomorrow, we're going to review this. This is going to be harder than doing the assignment for most of you. What? What page is it? You guys. My bad. Tomorrow, what we're going to do not turn this in when you are done. Tomorrow we're going to be adding to this. Do not turn it in. But do label it 4.1. Some of you are forgetting your section number. I'm going to start taking off if you forget to put that at the top of your paper. 4.1.